Okay, and we're back. These are going to be the last four for this board, and then we'll do the other two. I'm trying to decide what I want to do for the next couple of videos since there is only a couple days left. But it's just good practice. I mean, the videos are just my way of making myself accountable for them. But yeah, we'll just go ahead and start. So this is going to be nucleophilic addition to your carbonyl bonds, right? So your aldehydes or your ketones, plus nucleophile, right? And then these are going to be carried out by reducing agents. Reducing agents. And then this is going to make alcohols, right? And you'll see why in a little bit. But pretty much overall, you're going to be breaking a double bond and then making two single bonds. Right. Plus, like, you're going to extend a little bit. But pretty much what's going to happen, we will just use an aldehyde, is that this oxygen is going to pull the electrons away from this carbon, right? Because it's more electronegative, making it partially positive. And then this nucleophile, right, is going to be a nucleophile. So it wants the nucleus, which is positively charged, so it's going to be negative because opposites attract and whatnot. And then so pretty much when you add this nucleophile, you're going to attack it, right? And then that is going to cause a little bit of stress on this carbon, right? Because now it has 1, 2, 3, 4, 5. So it's going to kick these up here. And then that's going to make the oxygen negatively charged. And then since it's a reducing agent, the two that we're going to be using are going to be NaBH4 and LiAlH4. And what these are going to do, these are going to help like calm down that oxygen, and it's going to eventually make it that alcohol that we were talking about. Right, so we're going to be breaking this bond. This double bond gets broken, and we're going to make a new single bond. Right, there's one single bond, and then that second single bond is actually going to be in this alcohol, right? So two. So that's how we break one, make two. And then little Grignard reagents, right, are going to be a version of this nucleophilic addition, but it's going to have Mg, right? It's going to have a halide and then an R group. And then R group. So just for an example, we're going to have this guy, right? And we'll do it as an aldehyde this time, plus Mg. Let's just go BrCH2CH3. And then the overall reaction for that is going to be, we're going to make that an alcohol. And then we're going to add this. We're not going to add any of those. But we're going to add the CH2CH3. And then in solution, you're going to have MgBrOH. Plus MgBrOH. And that's pretty much for that. So you're just making alcohols, right? Making alcohols. And then we're going to do acetal. We'll start with hemiacetal. And pretty much all that is going to be a carbon with an OR group and an OH group on it. And then it's either going to be an R group or a hydrogen on the other two. But that and that is important because then we have an acetal, which is going to have that same carbon, and it's going to have one OR group and then another OR group instead of that other hydroxyl group. And then these again, it's going to be an R or an H. And to do this, we just react our aldehyde slash ketone plus a primary alcohol, right? And then you're going to get a hemiacetal every single time. But then from this, you can take that same hemiacetal and then react it with another primary alcohol. And then this time you get an acetal. And then that's just how that... Oh, and then this has to be done in acidic conditions. And yeah. Coolio. We move on. Imine versus enamine. So your imines are going... and then the ene, like an amine, right? We're going to be dealing with nitrogen here. But your imine is going to be an N R H, and then that's going to have that, and then that's going to be your base of that, and it's going to be aldehyde slash ketone plus primary amine, and then your enamine is going to be this structure. And there's going to be a double bond here now, and that's going to be your aldehyde slash ketone plus secondary amine. Right, and then this is going to be a little odd. This has a double bond here. That makes more sense. But pretty much for your imine, right, you're going to take... So you're going to start with the carbonyl bond, and then you're just going to swap the O for whatever amine you have. Swap with N, right? N, and then whatever R group, right? With primary amine, right? It's just a simple swap. Enamine is a little different. So you're going to have your carbonyl, right? And you're going to make double single. Double becomes single. Secondary amine. Double becomes single. R, right? And then that double bond is actually just going to flip-flop to one of these two, right? So you're either going to have a double bond here or a double bond there. It all depends on stability. Whichever one's the most stable will be the most